Welcome to another wonderful section of organic chemistry made easy with Basi Ejogba. And so far so good, we have been able to cover up what the basic introduction of what organic chemistry is all about, the hybridization aspect, and also the hydrocarbons, which is the alkenes in particular. We have talked about the general characteristics of alkenes, we have talked about the reactions of alkenes, and we have also talked about the preparation of alkenes. And today we'll be entering a very important concept as far as organic chemistry is concerned, and it is known as what? The alcohol, right? So the alcohol is actually what? A functional group. And remember when we talk about the functional group, right? We say the functional group determines what? The reactivity of a compound, right? So today we are going to talk about the functional group that is known as what? The alcohol. Now note, the alcohol, the name alcohol is also known as what? Alkanols. It's very, very important that you note or know another name for what? Alcohol. So another name for alcohol is also known as what? The word alkanols. Right? So the alcohol is also known as the word alkanols. And they have a general molecular formula of CnH2n plus 1 OH. They have a general molecular formula. So this is the general molecular formula of alcohols. We say general molecular formula. This is general molecular formula, right? So of what? That is say what? CnH2n plus 1 what? OH. Now it is very, very important to note that this OH here is the what? Functional group. This is the OH. This is what differentiates or what this the moment you see OH in a compound or in the name of a compound, it tells us that what they are talking about is what? The alcohols. So when you see the OH at the end of a what? Compound name, you reference the name to what? Alcohol. So we are going to talk more about it. I will talk more about it. So let's continue. This alcohol, they are what? sp3 hybridized. Remember I talked about the hybridization, right? Talked about the sp3, talked about the sp2 and the sp hybridization. So alcohol are what? sp3 what? Hybridized, right? They are sp3 hybridized. So the alcohol is what? sp3 hybridized, and due to the presence of what? Oxygen. Due to the presence of oxygen, they are referred to as what? Non-hydrocarbons. Due to the presence of oxygen, they are referred to as what? Non-hydrocarbons. So alcohol are what? Non-hydrocarbons. Alcohols are referred to as what? Non-hydrocarbons. Their functional group, remember I already said this in the beginning of this video. I said their functional group is the word OH, which is the word hydroxyl. And this functional group is confined to what is known as the alkyl group. The functional group, which is the word OH, is confined to what is known as the word alkyl group. So this is how it's going to look like. This is how it's going to look like. So we have our R and we have our word OH. So now the OH here is the word functional group and the R is the word alkyl group. So we say what? The alkyl group, and this is the word hydroxy. It is very, very important you take note of these points. So let's move on. Now alcohol has what? Various what? Classification. We are going to move on straight up to the classification of what? Alcohols. So let's move on to the classifications of what? Alcohols. Let's move on to the classification of what? Alcohols. So talking about the classification of alcohol, alcohols are classified into 4 based on the number of their what? OH. Remember the OH is the what? Functional what? Group, and they are classified into 4 based on the number of their what? OH. So number 1 classification of alcohol is what is known as the what? Alcohol monohydrate. I'm not going to write it, but I will when I want to start explaining them one by one. So the first one we have is the alcohol monohydrate. The second one is we have is the what? The alcohol dihydrate. The third we have is the what? Alcohol trihydrate. And the fourth we have is the what? Polyhydric what? Alcohol, the what? Alcohol what? Polyhydric. So let's start with the first one, which is the what? Alcohol what? Monohydrate. Let's talk about the what? Monohydrate what? Alcohol. So let's talk about the first one, which is the what? Alcohol what? Monohydrate. So let's say number 1, classification of alcohol, right? Say what? Classification of what? Alcohol. So we say classification, right? So we say number 1, we say what? Monohydrate what? Alcohol. Mono. From the name monohydrate, right? Means one. Mono means one. So we say monohydrate alcohol. So we say what? Monohydrate what? Alcohols, right? So now monohydrate alcohol this is a classification of alcohol that have what? One hydroxy group, that is one OH attached to their alkyl group. They have one hydroxy group attached to their what? Alkyl group. So we say have one hydroxy group. They have one hydroxy group attached to their alkyl group. So they have what? They have one hydroxy attached to their alkyl what group. So this is how it's going to look like. Let me give you a compound, and from there we will be able to get the name. So let's say we have a 4 carbon atom. Yes, we have a 4 carbon atom. All right, we have our 1, we have our 2, 3, and 4. Right, and we have our OH here. Am I correct? Yes. Bonded by our hydrogens, right? So we have our hydrogen located here. Right? We have our hydrogens over here. This is our H. We have, okay, there is a bend here. So over here, we have a branch carbon. We have a branch carbon here, right? Still bonded by hydrogen, still bonded by hydrogen. Remember, a carbon must be bonded by hydrogen. Then over here, we have our bonding, right? So now this is an example, a perfect example of what? Monohydrate what? Alcohol. They have one hydroxy group attached to their what? Alkyl group. When you see something like this, you get to see that the hydroxy group, which is the what? OH, right, is just represented 1. There is no, if you get to see the whole of this reaction, the OH is not what? 2. Right? It just have we have what? Just 1 OH. Now we have to get the name of this what? Compound. You have to get the name of this compound and the rules of what? Nomenclature, right? Nomenclature when it comes to organic compounds nomenclature, right? That is the organic compound naming. Basically, we have what? 5 carbon atoms here, because we have what? We have 1, we have what? 2, we have what? 3, we have what? 4, and we have what? 5. So we have what? 5 what? Carbon what? Atoms. I remember the families when I was talking about the families, right? And the members of the family. Remember, we have the alkanes, we have the alkenes, and the what? Alkynes. Basically, this is what? Alkanes, right? So when you get to mention 5, this is 1, 2, 3, 4, 5. Automatically, the name is what? Pentane, right? So the name is pentane. We are going to write pentane. We are going to write pentane in one other place. We are going to keep our pentane here, right? So now we check out where the branch is coming from, right? We check out where the branch is what coming what from. So let's check out here, right? Let's check out. All right, sorry. I'm sorry. This compound here. This compound here still goes down. This compound here still goes down from what I have here. All right. So this compound still goes down. Basically, the name of this compound is what? 3 what? Methyl. Right? The name of this compound is what? 3-methyl penta what? 1 all. We have what? 3. We have our 3-methyl penta. 3-methyl penta 1 what? All. That is basically the name of this what? Compound. 3-methyl penta 1 all. It is 1 all because there's what? Just what? It is a primary, it's a monohydrate alcohol because it just has what? 1 what? OH. As we continue along the line, you will get to understand more of what I am saying. So we move on to the second one, which is known as the dihydric alcohol, right? We're moving on to the second one, which is the what? Dihydric alcohol. So I'm going to clean this mono because it's basically almost same thing I'm going to say. So we are going to say dihydric alcohol. Right, we are going to see dihydric alcohol. Now dihydric alcohol contains 2 hydroxy group, so we are going to clean 1 and say what? 2, right? They have what? 2 hydroxy group attached to their what? Alkyl what? Group. They have 2 hydroxy group attached to their alkyl group. I don't know what is wrong with this shit. Oh, I don't know what is wrong with this thing. All right, so we're talking about the what? Dihydric what? Alcohol, right? We said they have 2 hydroxy group attached to the what? Alkyl what? Group. So we have a perfect compound here. We have a compound that is C, and C, right? We have our H, we have our OH bonded by our H, we have our H and our H here. and we have our OH bounded by H and what? H, right? Now, if you get to see a difference between the first one I did and this one here, you get to find out that this particular name or this particular compound, sorry, has two what? OH, right? So when it has two OH, it is known as the what? Dihydric what? Alcohol. It is known as what? The dihydric what? Alcohol. And it contains what? Two hydroxy what? Group attached to their what? Alkyl group. So what is the name of this compound? We already know that when it is 3, it is what? Propane, right? When it is 3, it is what? Propane. Now we have two OH attached. So we have carbon number 1 and carbon number what? 3, right? We have carbon number 1 and carbon number 3. So the name of this compound is going to be what? Propane 1,3-diol. So the name of this compound is what? Propane 1,3 what? Diol. It is di because it is what? 2 hydroxy what? Group, or because the hydroxy group there is what? 2. The moment it is 2, we don't say 1, 2 hydroxy. We simply say what? Di what? All. So what we have here is what? Propane what? 1,3 what? Diol. So let's move on to the next one. All right, we also have another name here. We have another compound that was given to us. We say we have our C and our C, right? With our H and our what? H and what? H, right? With also our H and our what? OH and our what? OH, right? Now the name of this compound is known as what? There are 2 carbons, right? It is ethane, right? Ethane, right? So this is what? Ethane 1,2-diol. Ethane 1,2-diol is also known as what? Glycol. So simply say this is what? Known as what? Glycol. Because ethane 1,2-diol is also known as what? Glycol. Let's move on to the third what? Classification of what? Alcohol, which is what? Trihydric what? Alcohol. So let's move on to our trihydric what? Alcohol. So when they will still have the same definitions. They will still have the same definition, but I believe by now you already know what is what applied. So we have our what? Trihydric what? Alcohol, right? So but when it comes to the trihydric alcohol, they are going to have what? 3 hydroxy group attached to the what? Alkyl what? Group. So we are going to change from 2, right, to what? 3 what? Hydroxy what? Group. So we are going to have 3 hydroxy group attached to their what? Alkyl what? Group. So like I said, say contain 3 hydroxy group attached to their what? Alkyl group. So we have the name here. We have a compound, right? We have a compound T, C, and what? C, right? With our what? H. I believe you are following up the class. If you have any clarification, if you need any clarification, drop it in the comment section and I will be glad to respond to it. So we have our OH here, right? We have our OH, we have our OH, and we have our what? OH being bonded by our what? H and our what? H, H, and what? H, right? Drop it in the comment section. Do you know the name of this compound? Do you know the name of this compound? So basically, you get to find out that the trihydric alcohol has what? 3 OH. You get to see there's a OH, right? You get to see that there's another OH, and you get to see that there's another what? OH. So when it is 3, remember I said when it is 3, the name is what? Propane, right? That is the members of the what? Hydrocarbons what? Family, right? So the name of this compound, since there are 3 OH, it's not going to be what? Diol, right? It's not going to be diol. Rather, the name is going to change to what? Triol. So the name of this compound is simply what? Propane what? 1, 2, 3 what? Triol. We have what? We have our propane. We have our propane what? 1, 2, 3 what? Triol. This is the name of this compound. We have our propane what? 1, 2, 3 what? Triol. Now propane 1, 2, 3 triol is also known as what? The glycerol. So our propane 1, 2, 3 triol, the name of this compound, which is what? Propane 1, 2, 3 triol, is also known as what? Glycerol. Remember when I talk about the ethane 1, 2, the ethane 1, 2 diol, right? I say it's known as glycol. So the propane 1, 2 triol, 1, 2, 3 triol is also known as what? The glycerol. So the name of this compound is what is known as what? Glycerol. It is very, very important you take note of these names because the namings are very, very important. So now let's move on to the last classification of alcohol, which is known as the what? Polyhydric what? Alcohol. So we clean here and we clean also this compound. Then also this compound. I am not saying that what I am doing here is supposed to end at propane, right? The name continues. You understand? The name of continues. Emphasis on the what? Carbon atom that is what? Present, right? Emphasis on the numbers of the carbon atoms that is what? Present. All right, my mic is still on. Checking my mic. Emphasis on the carbon atom that is what present. You can get to what name. But when you are naming it, you have to pay close attention to the number of what hydroxy group or the number of the what OH that is what currently what available in that what structure or in that what compound. So let's move on to the next one, which is the what polyhydric what alcohol. So for the polyhydric alcohol, they contain more than three. So we say what? More than three. We are going to say here that more than. So more than three what? Hydroxy group attached to their what? Alkyl what group. A basic or a simplified example of the what? Polyhydric alcohol is what we call what? Glucose. Is what we call what? Glucose. 6,6 H12 what? O6. Glucose, which is what? C6H12 what? O what? 6. This is a perfect example of what? Of a what? Polyhydric what? Alcohol when the OH or the number of the hydroxy group is more than what? 3. So just know that it is what is known as what? Alcohol. Sorry, the classification of alcohol, that is the glucose, right, is a what? Polyhydric what? Alcohol. It is very, very important because you can get to see this in your exam. Example of a what? The polyhydric alcohol, right? Just know that it is what? Glucose. Example of a polyhydric alcohol is what? Glucose. Example of a trihydric alcohol is what? Glycerol, which is what? The propan what? 1, 2, 3 triol. Example of a dihydric alcohol is what? The what do they call it? What is the name? The glycol, right? That is the ethan 1, 2 what? Diol. So now let's move on to what is now. I want to talk about this alcohol monohydrate, right? We want to talk about alcohol monohydrate in person. That is, we are not just going to say alcohol monohydrate contains one hydroxy group attached to the alkyl group. Now we are going to simplify the word alcohol what? Monohydrate. Now alcohol monohydrate being, so we are going to clean this, right? We are going to clean this, and emphasis will be laid on alcohol what? Monohydrate as a what? Sub what? Topic. So we are going to say what? Alcohol what? Monohydrate as a what? Subtopic. Alcohol what? Monohydrate as a sub what? Topic. So under alcohol monohydrate as a subtopic, alcohol monohydrate is simply classified into what? The following, and it's simply classified into what? 3. We have what is known as the primary alcohol, we have what is known as the secondary alcohol, and we have what is known as what? The tertiary what? Alcohol. So we have number 1, which is what? The primary alcohol. We have the primary alcohol. We have number 2, which is the what? Secondary alcohol. We have the secondary alcohol, and we have the third one, which is what? Our tertiary what? Alcohol. We have our tertiary what? Alcohol. It is very, very important you take note of this what point. So we are going to talk about what is our primary alcohol. We are going to talk about what is secondary alcohol, and we are also going to talk about what is tertiary alcohol. And from there, we are going to talk about the namings of alcohol, how you can be able to name what alcohol. But naming of alcohol is very simple. You pay emphasis, or you pay attention to where the OH is what located. The OH is the functional group. You start counting where the OH, where the functional group is what located, and that is what basically I'm going to talk about. So let's talk about the primary alcohol. So let me just clean the secondary alcohol and the tertiary alcohol off from the picture, right? So the primary alcohol, you can write, right? Primary alcohol is a type of monohydrate alcohol that has 2 or 3 hydrogen atoms attached to the carbons that bears the word OH. So let me write this for you. I say what is a type of what? Monohydrate alcohol, right? It's a type of monohydrate what? Alcohol. It's a type of monohydrate alcohol that has, it's a type of monohydrate alcohol that has 2 or more or 3, sorry, that's 2 or 3 hydrogen atoms attached to the carbon that bears the OH, that bears the what? OH, that bears the what? Functional what? Group. So basically this definition already is what? Self what? Explanatory. This definition already has already given us the explanation of what we are what? Supposed to what? Expect. So what this is simply saying is what? It's a type of what? Monohydrate alcohol. Primary alcohol is a type of monohydrate alcohol that has 2 or 3 what? Hydrogen what? Atoms attached to the carbons that bears the word OH. So basically what we are going to have is a carbon, right? And note that a carbon is supposed to be bonded by 4 hydrogen atoms. That is what a standard. Am I correct? Yes. A carbon is supposed to be bonded by 4 hydrogen atoms. That means what we are supposed to have is something like this. Am I correct? So what we are supposed to have is something like this. A carbon being bonded by what? 4 what? Hydrogen what? Atoms. But when it comes to what? A primary alcohol, which is a type of what? Monohydric alcohol, it's just going to have what? 3 hydrogen bonding the carbon that bears the word OH. So basically what we are going to have is our OH here and being bonded by what? 3 what? Hydrogen what? Atoms. So we are going to have the first hydrogen and the third hydrogen. So this is what is known as what? A primary what? Alcohol. And the name of this is very, very what? Simple. When a carbon is just what? 1, it is known as what? Methane. But there's a presence of the OH. So the name is no longer going to be what? Methane. The name is now going to be what? Methanol. So this is what is known as what? The methanol. Right, so this is what is known as what? Methanol. It is all because of the presence of what? Alcohol, which is the word OH. That is why the name now changed to what? Methanol. It is very, very important you understand this. This can also shift to as long as possible. So let me give you another one that is here. We have our C, and we have our C. We have our OH, right, and we have our H. It's very, very important. Look at the board. And we have our OH. Now, if you get to find out this particular carbon, right, is just bonded by 2 hydrogen. And this particular carbon is being bonded by 3 hydrogen. Remember our definition of the word primary alcohol. It can be bonded by what? 2 or what? 3 what? Hydrogen what? Atoms. And now from the name of this is what? 3 carbon atoms. So basically the name of this compound is what is known as what? The propanol. So the name of this compound is what? Propanol. The name of this compound is simply known as what? The propanol. So let's move on straight up to what? Secondary what? Alcohol. So the secondary alcohol, let's just clean our primary. We are going to clean our primary and we are going to clean this compound or this structural formula here on the board. So we are going to clean this, right? Yep. And we are going to write our OH. So we are going to say secondary alcohol. We are going to say what? Secondary what? Alcohol. Now, the secondary alcohol is a type of monohydric alcohol that has only 1 hydrogen atom. Pay attention. Only 1 hydrogen atom attached to the carbon that bears the word OH. Only 1 what? Hydrogen atom attached to the carbon that bears the word OH. So we are going to clean 2 or 3, right? We are going to clean the 2 or 3. We are going to say that has only 1 hydrogen atom attached to the carbon that bears the word OH. So we also have, so I'm going to clean atoms because it's just 1. So it's what? Hydrogen what? Atom attached to the carbon that bears the word OH. So we are going to have the name. We are going to have a compound where we are going to name in order to understand what I am saying. So we have our C, right? And we have our C and our what? C, where we have our H, right? And we have our H and we have our H, right? And we have our OH, and we have our H, and we have our H, and our H, and our what? H. If you get to check here, there's a OH here, and it is being bonded, by only what? 1 hydrogen what? Atoms, right? So to name this compound is as easy as what? Possible. This is already propane, right? This is already propane. So we count, right? So we say what? 1, 2, right? So our OH falls at what? Carbon number what? 2. So the name of this compound is going to be what? Propan what? 2-ol. So what we have here is what? Propan 2 what? Ol. So we have our propan what? 2 what? Ol. That is basically what we are having what here. So let's move on to what? Tertiary what? Alcohol. So for the tertiary alcohol, so we have our tertiary alcohol, right? So we have our what? Tertiary what? Alcohol. So the tertiary alcohol is a type of monohydric alcohol that has no hydrogen atom. So we say that has no what? Hydrogen atom attached to the carbon that bears the word OH. Tertiary alcohol is a type of monohydric alcohol that has no hydrogen atoms attached to the carbons that bears the word OH. So we are going to see this through this word compound. So what we have here is what? We have 2-methyl-butanol. Okay, 2-methyl-butan 2-ol. We have 2 2-methyl-butan-2-ol. I'm not going to write it on the board. Yes, I'm not going to write it on the board. Excuse me. We are not going to write 2-methyl-butan-2-ol. I'm not going to write it on the board. But if you watch this video, I want you to do it as an assignment and submit to me on WhatsApp. My WhatsApp number is 07062462746. My name is Basi Ejogba. So you say, well, Basi Ejogba, right? So make sure you drop this assignment on WhatsApp for me. Drop this assignment. Let me know whether you're actually following up. Give me the name of 2-methyl-butan-2-ol. 2-methyl-butan-2-ol. Draw the structure, snap it, and send to me on WhatsApp. So let's continue. We said note. Remember there was a time we talked about what methanol as an example of what a primary what alcohol. And a primary alcohol is an example of what a monohydrate what alcohol. It is very important you understand this what concept. So we are going to leave. This. We said note. Note, it's very important you understand this concept. Methanol is also called what? Carbinol. Methanol is also known as what? Carbinol or what? Wood spirit. So you say methanol is also known as what? Wood spirit or what? Carbinol. Methanol is also known as what? Wood spirit or what? Carbinol. Now, wood spirit or what? Carbinol. Note also that methylated spirit, the methylated spirit we use, methylated spirit contains 95% ethanol. You say what? Methylated spirit contains what? 95% ethanol and 5% methanol. Methylated spirit contains what? 95% what? Ethanol. 95% ethanol and what? 5% what? 5% methanol. That is the what? Composition of what? Methylated what? Spirit. That is the composition of what is known as what? Methylated spirit. 95% ethanol and what? 5% what? Methanol. Also note that methanol is formed from the what? Destructive distillation of what? Wood. Methanol is formed from the destructive distillation. Is formed from the what? Destructive what? Distillation of wood. Methanol is formed from the what? Destructive distillation of what? Wood. So basically, that is everything you are supposed to know when it comes to what? Alcohol in what? Simplified way for your level, 100 level in the university. 100 level in the university, an introductory aspect to organic chemistry at that what level. This is basically everything you are supposed to know about what alcohol. We have already talked about the alcohol and their what various what characteristics. We say they are what sp3 hybridides, and another name for alcohol is also known as what? The alkanols. So what we are going to move right now is I'm going to teach you how to name what? Alcohol. I'm going to teach you how to name what? Alcohol. So what we are doing right now is known as what? Alcohol what? Nomenclature. Nomenclature is also known as what? Naming. So that is basically what we are going to do. So let's clean this and clean this and clean this, and we are going to say what? Alcohol what? Naming. Or we say alcohol what? Nomenclature. Anyone you want to use, you are what? Free. Any of the words you are going to use. Remember, I already told you that when naming, emphasis or what? Respect is given to what? Where there is a presence of what? The OH, right? You start counting where there is a presence of what? OH. So in the naming of alcohol, all alcohols must be named, putting their OH in what? Consideration. Number one, you say what? All alcohols must be named, putting their OH, right? Putting their OH into what? Consideration. All alcohol must be named, putting their OH into what? Consideration. Like I already said, when you want to name alcohol or when you want to start counting when it comes to what? Alcohol, you start counting giving respect to where there's what? OH. So you don't just jump the OH and start counting from another place. You must give respect to where there's what? An OH. So let's move on to the number two. When I finish the number two, I'm going to show you how you are going to what name this what alcohol. So number two is consider the substituent groups when naming alcohol. It says consider the substituent group, consider the substituent, right? Consider the substituent group, consider the substituent group when naming what alcohol, when naming alcohol, right? It is very, very important you understand. It says number one, in alcohol nomenclature, it's as simple as what ABCD. All alcohols must be named putting their OH into consideration. Consider the substituent group when naming what alcohol. So let me just give you this structure. Let me give you this structure so that you'll be able to know what we are doing here. Let me show you so I can be able to know what we are doing here. So basically what we have here is a structure, right? What we have here is a structure. Let me see. We have 1, 2, 3, 4, 5. So what we have here is a structure of pentanol. What we have here is this, right? I'm following from what is here because this is my note of lesson. So basically everything I do, I'm flowing from here. So we have our what OH. Now this is known as what pens because it is just what 5. We have 1, 2, 3, 4, what 5. So to name this, we are going to start our counting where there's a presence of what OH, right? So this is number 1. So basically the name of this compound is known as what cyclo what pentanol. So the name of this compound is known as what the cyclo what pentanol. So the name of this compound is known as what the cyclo what pentanol. There are a lot of them and a lot of what them. If you want to connect with me, chat me up on WhatsApp on 070-6246-2746. And I will be glad to put you more on what you are supposed to know. So basically right now, we'll be moving to another section of alcohol that is very, very important, and that is what is known as what phenol. That is so the next concept we are going to talk about, which is also related to the word alcohol, is what is known as what phenol, which is here on the board. So phenol is also known as what benzenol. Phenol is also known as what benzenol. It is very, very important you take note of this point. Phenol is also known as what the benzenol. The phenol is also known as what the benzenol, and they are made up of what 2 groups. The phenol is made up of what 2 groups. The phenol, which I can decide subsequently to call the word benzenol, is made up of what 2 groups. Now the first group, remember when I was talking about the alcohol, right? And I said the alcohol is made of 2 groups, the alkyl group and the what hydroxy what group. When it comes to the phenol, which is the benzenol, it is also made of what the alkyl group, but at this particular time it is no longer called alkyl. It is known as what the aryl. You understand? It is no longer called alkyl, rather it is called what aryl, and I'm going to explain why it is called the what aryl group. So basically the first group is the aryl group. So we have the what aryl group, we have the aryl group, and the second one is the what hydroxy group, which is the what OH. Remember the other time I talked about the word alkyl word group, but right now the name has changed from what alkyl to what aryl. So what is aryl? What is what the aryl word group? Now the aryl group or aryl is simply what a benzene. The aryl is simply what a benzene that has lost 1 hydrogen. Aryl, please take note. My marker is not. Please take note. Aryl this thing is no longer writing, but aryl is a benzene that has lost 1 hydrogen. Please write it down. Aryl is a benzene that has lost 1 hydrogen. So any benzene that has lost 1 hydrogen, it is known as what aryl. So let's see whether I can see right here. See aryl, right? Aryl, right? A benzene that has lost 1 hydrogen. So a benzene that has lost 1 hydrogen is called what the word aryl, and this is how it is being what represented. So we have our what benzene, right? So basically we have our benzene. This is our what benzene with our word OH. Remember I talked about the word OH, right? So this is our aryl. Now with this particular structure is what is known as what phenol. This particular structure is what is known as what phenol. So this structure here is known as what? Phenol. So what we simply say is what? Aryl, right? Plus what? OH is equals to what? Phenol. Aryl plus what? OH equals to what? Phenol. It is very, very important that you take note of this what? Point. So basically from here, we can be able to know the names of what? Compounds, right? We can be able to know of the name of what? Compounds when it is being what? Presented. So let me clean all this so that we are going to have more space. So from here, we are going to know the name of compound when it is being what? Presented. So let's name at least two compounds before we proceed. So let's name at least two compounds. So what we have here is this. So let's go into naming. Basically, okay, let's say what we have here, this is the first compound we have. So this is the first compound we have here, right? With our word OH, right? And what this, we have our what CH3 what located here. We already know that the CH3 is what? Methyl. But now what we are going to do is this: how we can be able to name this what? Compound. That is what we are looking for. How we can be able to name this what? Compound. So remember I told you how to name what? Alcohols, right? In our alcohol nomenclature, we said emphasis starts on where there's what? A functional group. That is where we start laying our what? Value. Where there's what? A functional group. So there's a functional group here, which is the what? OH, right? So our counting starts with what? The OH, which is number 1, and our methyl is our what? Number 2. So basically the name of this compound is known as what? 2-methyl-phenol. That is the name of this compound. We say what? The 2-methyl what? Phenol. That is the name of this what? Compound. 2-methyl what? Phenol. With this also, I can be able to manipulate a lot of what? Names. But note that the moment I draw the structure, I must always put my what? OH. I must always present my OH, because with my OH, I will get to know that this is what? Phenol I am talking about. So let's also move on. Let's assume, okay, let's assume I am going to clean the CH3 at carbon number 2, which is facing my right. Let's see how I can take it to my left. So let's assume I represent this here, and we have our CH3 and our CH2. We have our CH3 and our CH2. Note, naming, when it comes to organic compound, or when it comes to organic chemistry, and you want to name what? Compound, right? You give the substituent the lowest possible number, right? Like I said, consideration must be given to the substituent. So our counting is no longer going to take what? Clockwise. Rather, our counting is going to take what? Anti-what? Clockwise. So what we are going to have here, but still emphasis must be given to where this what? OH, right? So our OH still represent what? Number what? 1, and here we have number 2, and here we have what? Number what? 3. So simply the name of this compound that is here, right? Remember this CH3CH2 is known as what? Ethyl, right? CH3CH2 is known as what? Ethyl. So basically it is ethyl because of what? It is 2 carbon, and ethyl because of the presence of what? A double bond. So basically the name of this compound is known as what? 3-ethyl-phenol. So the name of this compound is what? The 3-ethyl-phenol. The 3-ethyl-phenol. So this is just how it what goes, and from here you can be able to give us, can try to test yourself, practice questions, try to see how you can change the name to any other place, and see how you can still be able to what? Get it. So let's continue, right? Remember there was a time I talked about the word methyl-phenol. Note this. Methyl-phenol has a special name, right? So if I don't want to call it methyl-phenol, I can still decide to call it any other name, right? So the methyl-phenol has a special name that is known as what? Cresol. Methyl-phenol has a special name that is known as what? Cresol. So we say our methyl-phenol is also known as what? Cresol. Just as every other person, or I have my own special name, you have your own special name. So when it comes to methyl-phenol, it also has its own what? Special name. And the special name for this methyl-phenol is known as what? Cresol. Now, based on the position of the methyl, based on the position of the what? CH3, which is the what? Methyl, these phenols are grouped into what? 3. Based on the position of the what? Methyl. Please take note, the grouping of what? Phenol is based on the position of the what? Methyl. It is not ethyl, rather methyl. That is the CH3, 1 carbon what? Atom. So let's simply go on there. So we are going to say number 1, right? We are going to say number 1. We have our what? Let's put in our structure, right? So this is basically our structure, and there's our OH, right? And this is simply our what? This is phenol, right? So putting in our CH3, right? This is methyl. So based on the position of the word methyl, that is where we are going to have the grouping of the word phenol. So remember to you that counting must always start where there's OH, right? And respect must always be given to where there's a substituent. So we are going to say this is number one and this is what number what two. So what is the name of this word? Type of what? Phenol. This type of phenol is known as the word O-cresol or the word auto-cresol. So this type of phenol is known as what? The auto-cresol. So we say auto-cresol or what? O-cresol. It is the word autocresol or the O-cresol because it falls at what? Carbon number what? 2. It falls at what? Carbon number what? 2. When it falls at carbon number 2, the name becomes what? O-cresol. And in situations or exam situations, probably you go to the exam hall and you get to see structure like this and you don't see the name O-cresol and you get to see the name autocresol. Please note that the answer is also what? The autocresol. But in case you don't see the autocresol and you are seeing what? The O-cresol, please take note that it can also be called the auto or the what? O-cresol. So let me change the name. So let me change the position of the CH3, that is the methyl. So it is going to change from carbon number 2, right? So this is, forgive me, my diagram is not that fresh. You understand? That fresh diagram, but let me see. All right, so this is carbon number 3, right? So we have our CH3, right? Our methyl falls here at the CH3. So when the methyl falls at the CH3, the name is going to change, right? From the word autocresol or the O-cresol to what is known as the word metacresol. So the name automatically becomes what? The meta-cresol. Right, the name becomes what? The metacresol or what is known as what? M-cresol. So we say metacresol or what? M-cresol. The metacresol or what is known as what? M-cresol. Please, I'm checking up my mic because if this mic gets off, I am doomed. So we have our metacresol or our M-cresol. Still moving on the same pace, I'm going to change the position of the methyl group to here, right, to our CH3. So you get to find out that 1, 2, 3, 4, it is falling at what? Carbon number what? 4. So the name of this compound is simply known as what? The p-cresol. So what we have here is our what? P-cresol. Forgive me, my marker is no longer responding. So what we have here is what is known as what? The p-cresol. So this is our what? P-cresol. It is very, very important that you understand that methyl, or sorry, phenol is group based on the position of their what? Methyl. So this is known as a what? P-cresol. This is known as a what? P-cresol. I don't actually know what is wrong with this, but let me see how I can fix this up immediately. So basically, like I said, this is our p-cresol, and this is based on the position of the word methyl, that is the word CH3. Let's move on to another important concept as far as phenol is concerned, and that is what is known as acidity in phenol. Acidity in phenol. So we say acidity in what? Phenol. Basically, I don't know what's wrong with my marker. All right. Say acidity in phenol. Acidity in what? Phenol. It seems it's because this stuff is red. So we say what? The acidity in what? Phenol. Now let's write. We'll wait for the board to get dry up. So we say acidity is determined by the number of what? Hydrogen ions present in a particular sample of that what? Organic what? Compound. Acidity is determined by the number of what? Hydrogen ions. Take note. Acidity is determined by the number of what? Hydrogen what? Ions present in a particular sample of what? An organic what? Compound. Remember, there's something that's known as acidity and there's something that's known as what? Basicity. Basicity is simply the what? The number of what? Replaceable what? Hydrogen what? Ions. Right? That is what is known as what? Basicity. The number of what? Replaceable what? Hydrogen what? Ions. But what we are talking about right now is what? The acidity. And acidity is determined by the number of what? Hydrogen ions that is present in a particular sample of what? An organic what? Compound. So in alcohols such as what? Ethanol, it dissociates, right? In alcohols such as what? Ethanol, it will dissociate. So let me give you the formula for what? Alcohol for ethanol, sorry. So we have our C2, right? We have our C2. Sincerely, I don't know what's wrong with this. We have our C2H5OH. We have our C2H5OH. This is what our what? Ethanol dissociating with a forward and a backward reaction give us what is known as what the hydroxide what ion, which is C5AO minus plus what H what plus. So this is what ethanol dissociating to give us what hydroxide ion, dissociating to give us what hydroxide ion and what hydrogen what ions. This is what ethanol dissociating to give us what hydroxide ions and what hydrogen what ions. Now if you get to check, let me give you state to give hydroxide ion and hydrogen and what ion, but this reaction is what a reversible what reaction. That means this reaction can go forward and this reaction can also what come backward. As the hydroxide ion and hydrogen ions are formed, they combine back to form what ethanol. We already know this is hydroxide ion, hydrogen ion. They can combine back to form what ethanol, thereby reducing the concentration of hydrogen ions in that what sample. When they form back to give you what ethanol, when the hydroxide ion and hydrogen ion come together to combine to give you what ethanol, they reduce the concentration of what hydrogen ions in that particular what sample. And when it comes to phenol, remember we are talking about what phenol, but as we are talking about phenol, I have to chip in ethanol, right? I have to chip in what ethanol, because ethanol is a popular example of what alcohol, right? So when it comes to alcohol, right, it dissociates to give you what hydroxide ion and what hydrogen what ions, and this hydrogen ion and the hydroxide ion can still combine together to give you what ethanol, but when it combines together, it tends to reduce the what hydrogen ions in that particular what sample. But when it comes to phenol, it is not so. When it comes to phenol, it is not so. This is because the ionization of phenol is almost completely an irreversible what reaction. Take note to the dissociation of phenol is an irreversible reaction. Please take note. Take note of that point. Take note of that point. The dissociation of phenol is an irreversible reaction, but the dissociation of alcohol is a reversible what reaction, right? So let's continue. Phenol dissociates to give what phenoxide ions and what hydrogen what ions. Immediately the phenoxide ion is formed, the negative charge on the oxygen, I'm going to represent this, but let me read this in case you are writing. Immediately phenoxide ion is formed, the negative charge on the oxygen is donated to the nucleus of the phenoxide ions, and they begin to migrate from what one pi electron to the next, right, leading to a phenomenon that is known as what resonance. Leading to a phenomenon that is known as what resonance, hence leading to the accumulation of what hydrogen ions in that particular what sample. So when phenoxide ion is formed, you understand, when phenoxide ion is what formed, right, the negative charge on the oxygen, remember when I did the hydroxide ions and there was a negative charge on the what oxygen, right? So this negative charge on the oxygen is donated to the what nucleus of the what phenoxide ions, and they begin to what migrate from what one pi electron to the what next. Remember I've already talked about what the pi electron is. I've already talked about what sigma is, right? The sigma bond and the what pi what bond. So when they begin to move from what one pi electron to the next, they lead to what is known as what vibration, right? They start leading to what vibration, and this vibration in chemistry is known as what the resonance, right? So when they lead to this vibration, it leads to the accumulation of what these hydrogen ions in a particular what sample. Remember when it comes to ethanol, there's a loss of what hydrogen what ions, but when it comes to the phenoxide ions, there's what accumulation of what this what hydrogen ions, leading to what resonance, which is what a vibration, right? And the reaction of what phenol giving us what phenoxide ions and hydrogen ions is completely what an irreversible what reaction. So this is what we are going to have on the board. This is what we are going to have on the board, right? This is basically what we are going to have on the board, giving us a forward reaction, right? Giving us a forward reaction, O minus, right? Giving us forward reaction plus what? H what? Plus. This is O minus. So this is phenol dissociating without giving us a backward reaction, giving us what? Phenoxide ion, and what? This is what? Hydrogen what? Ions. Now remember when I said the oxygen, the negative charge on the oxygen will be donated to the nucleus. So there's going to be a movement here, right? So there's going to be a movement here, and this movement is known as what delocalization. The movement, the localization, like moving from one particular locality to another. So it's known as what the delocalization, right? So this is simply what delocalization. This is simply delocalization. The oxygen, the negative charge on the oxygen ion is going to be donated to the what nucleus. So what we are going to have is what phenol giving us what phenoxide ion plus what hydrogen what ion, which is what an irreversible what reaction. And in conclusion, it is very, very important that you note that phenol is more acidic than alcohol. Sorry, yes, phenol is more acidic than what alcohol. That is what I have here, right? The phenol is more acidic than what alcohol. It is very, very important that you understand this. Phenol is very, very acidic, or it's more acidic than what alcohol. So this is everything you're supposed to know when it comes to what the alcohol, which is what a functional group. I've talked about the characteristics of the alcohol, which is what I said. It is what sp3 what hybridized, right? And I said it's sp3 hybridized. Talked about the classification, which is what the monohydrate alcohol, the dihydroxy alcohol, the trihydroxy alcohol, and the polyhydroxy what alcohol, which we have been able to name a lot of them. And I also taught you how to name what alcohols, right? The nomenclature of alcohols, which will move on to the phenol, which has another name for the phenol, is also known as a what benzenol, and also another name for alcohol is also known as what alcohol. It is very, very important you take note of this point, because these are very important aspects when it comes to what organic what chemistry. Remember, I gave you an assignment. Make sure you do my assignment and chat me up on WhatsApp on 07062462746. If you want me to be your lesson teacher, your online teacher, I will be glad to help you make sure you ace your exams, whether you are preparing for post-UTME, whether you are preparing for your JAMB, or whether you are preparing for your WAEC, or even though you are a university student here in the University of Calabar, University of Cross River State, known as Screwtech or Unicross, or any university in Nigeria. Remember that organic chemistry is not a race. It is not a 100-meter race. Rather, it is what a marathon. It is something that you enjoy. It is a journey that you spend your time understanding. Note that with continuous practice, you will be able to get this. And if you are watching this on YouTube, please don't forget to hit on the red subscribe button so I can continue getting updated anytime I drop videos like this. And in turn, it will help me grow. But I'll see you in my next video. We'll be talking about the carbonyl group, where we are going to talk about the alkanones and the what alkanines. I really love you. Thank you.